The ongoing march of scientific discoveries continues. Get it? March. So here are 10 interesting scientific discoveries for March of 2026. Number 10. Strange early galaxy cluster defies the rules. Galaxy clusters and their formation is an area that is still full of mysteries in astronomy. There are ideas on how they formed, of course, but occasionally there are anomalies, and now there is a huge, rather glaring one that may change our understanding of galaxy clusters in general. Known as SPT 2349-56, this cluster from our perspective appears young, and we see it as it was 1.4 billion years after the Big Bang. This cluster is full of gas, but the problem is that this gas is far hotter than it should be according to our current understanding. Hot is almost an understatement. Near the center of the cluster, the temperature apparently exceeds several tens of millions of degrees Celsius. That's hotter than the surface of the Sun, which is between 5 and 10 times what was expected. This is not unknown for galaxy clusters in itself. They heat gas over time, but in this case, it's far earlier than was expected for a young galaxy cluster. The cluster also appears unique. No other examples of this are known, and it's thought that the culprit might be the presence of several active galaxies within the cluster that have huge jets coming from their cores that might be what heated the gas so rapidly, in which case this may represent a stage common to many galaxy clusters early on, but that we just happen to have caught this one in the act. Number 9. Poison arrows are older than we thought. Tipping an arrow with poison, usually a plant toxin, is an old and very widespread idea that until now was believed based on evidence to date back about 8,000 years. But in 2020, an analysis showed that some arrow points that date from between 50 and 80,000 years ago were consistent with poison arrow tips that are still in use today. That was a clue that the practice may have been far older, but not conclusive proof. Now we have the answer. Quartzite arrowheads found in South Africa in 1985 have been found to have traces of specific plant toxins. This is probably from a plant that is known to exude a toxic, sticky resin in its roots that can be applied to the arrow directly or be used to create a resin in conjunction with other substances to increase potency. The study actually found 10 arrowheads that had these traces, meaning that it was not accidental or coincidental, but a deliberate practice of poisoning arrow tips, pushing the date back for the invention of poisoned arrow points to about 60,000 years ago at least. Number 8. Missing star relocated after 130 years. In 1892, Edward Emerson Barnard observed a star that puzzled him. His claim to fame was finding a fifth moon of Jupiter, but several weeks before that, he observed what he thought was a star near Venus shining at about 7th magnitude. So he checked star charts going to magnitude 9.5, and the star simply was not there. All he saw in the same position was a much, much dimmer 11th magnitude star, about 100 times less luminous. This ghost star was an enigma for a century, with some astronomers wondering if Barnard had caught a dramatic brightening of a normally dimmer star, but others wondered if it was an optical effect of his telescope due to bright Venus being in the field of view. It actually was neither. An optical engineer at the University of Arizona recreated Barnard's basic setup with a period eyepiece, and he looked at Venus in the early morning. He immediately noticed a star that appeared bright, but was listed in his star charts at a much dimmer 8th magnitude. It turns out that in the early light of dawn, that type of optical setup can make a star superficially appear significantly brighter than it actually is, and that the 11th magnitude star Barnard saw was in fact his missing 7th magnitude star. Number 7. Leave sleeping jellyfish lie. Jellyfish are not mammals, and they do not have brains as we know them. Rather, they have networks of neurons that span their bodies. However, it's long been known that jellyfish, despite being very different from a human, do in fact sleep. But little was known as to why they needed to do that, or what their patterns were. Researchers used a species of jellyfish that sits on the seabed with its tentacles upward, the opposite of most other jellyfish species, and they exposed it to simulated night and day cycles. When exposed to light, the jellyfish pulsed rapidly and responded to the presence of food or changes in lighting, suggesting that they were awake. When in dark, however, they pulsed much slower and showed markedly longer reaction times to any stimulus, suggesting they were asleep. It turns out that jellyfish averaged about 8 hours of sleep a night like a human, with a nap in the middle of the simulated day of 1 to 2 hours, much like many humans. Moreover, the researchers used water jets to disrupt their sleep, and the result was the jellyfish slept longer the next day, again, much like a human. Number 6. The age of artificial lungs has begun. In 2023, a 33-year-old patient at Northwestern Memorial Hospital was fighting a severe case of influenza who had caught a secondary infection and was very near death. The patient's heart actually stopped, but doctors were able to get it beating again. A double lung transplant was considered, but the patient was simply too sick to survive the surgery. The patient was going to die regardless without working lungs, even though a system exists to oxygenate the blood, but it still requires the patient to have lungs because of how blood circulates in the body, and if that's compromised, then it doesn't work. Here, doctors came up with a procedure that involved oxygenating the patient's blood while pumping blood from the right to left side of the heart before sending the oxygenated blood onto the rest of the body, effectively functioning as an artificial lung. The patient's actual damaged lungs were removed, and the procedure kept the patient alive without lungs for 2 days, until he had recovered sufficiently from the secondary infection to go through with a lung transplant, and the patient survived and is alive today. Number 5. The problem with protons. One maddening area of science has been nailing down the actual size of the proton. Numerous measurements were taken to try to determine that, but they disagreed to the point that a key test of the standard model of particle physics could not be performed, at least with the desired precision. However, a new measurement actually has done it, bringing it down to 1/10 of a billionth of a percent error. The researchers did it by studying hydrogen and the frequency of radiation needed to get the atom to jump between 2 different energy levels. That, along with other measurements, nailed down the size of the proton to 0.84 trillionths of a millimeter. This agrees with some previous measurements, but is actually 4% smaller than the most widely suspected size. As it turns out, the standard model survived the test in this case. Number 4. Tyrannosaurus rex took 40 years to reach adulthood. Recently, the largest ever analysis of the existing T-Rex fossils yielded a surprising fact. It took them 35 to 40 years to reach maturity. This is tricky because there is also some debate about whether smaller T-Rex specimens are in fact juveniles or represent a different species of dwarf tyrannosaur. Previously, it was thought that these dinosaurs reached their maximum weight of about 8 tons within about 20 years, and then only lived about a decade longer. This appears to be incorrect and was based on a smaller sampling of fossils. The new study involved fossils from 17 individuals and looked at everything from bone tissue structure or growth rings, which are incomplete as the marrow destroys the earliest ones, making it essential to look at specimens of all ages. The result was that the T-Rex grew slower than what was thought, and the rate varied with the conditions the dinosaur was living in. This places a maximum lifespan of a T-Rex at 40 years, probably longer, but it was noted that only 2 of the skeletons were full-grown. The rest were not mature, suggesting that many T-Rexes died before reaching fully grown. Number 3. More evidence for human protowriting. One of the most interesting aspects of early human history are the often very detailed and complex cave paintings that people did. While the animal depictions are clear, what isn't clear are the various dots and symbols that are often found alongside these paintings, or at least some of them. These marks have been hypothesized to be a kind of precursor to actual writing, but instead a type of proto-writing. Now, other evidence that this might be the case has surfaced. Dots and dashes have also been identified on carvings, including ivory artifacts, including one of a mammoth dating to about 40,000 years ago, but also flutes and other carvings. By studying such artifacts found in Germany from the Aurignacian period, some of the earliest Homo sapiens to arrive in Europe, they found out of thousands of such markings, there were only 22 characters represented. They compared that to another known form of proto-writing, which is the much later Proto-Cuneiform of Mesopotamia, but they also compared it to modern writing systems. What they found is that there is a pattern, just like a written language has, or protowriting. Some of the marks are hypothesized to be some kind of calendar. While these cannot be deciphered, there's no Rosetta Stone here, another thing became clear. This system of protowriting, if that's what it actually is, remains stable for over 10,000 years, also strongly suggesting that this is in fact protowriting. Strangely, there is also much more recent evidence, in fact from Mesopotamia, in the form of a painted pottery fragment about 8,000 years old, that shows designs of floral patterns with 4, 8, 16, 32, and 64 petals, suggesting an advanced state of mathematics at the time. More than what was thought before the Sumerians 2,000 years later came up with base 60 mathematics. Number 2. The genome of the woolly rhino. About 14,400 years ago, something a bit sad happened in northern Siberia. The mummified remains of 2 wolf pups were found. What seems to have happened was that the roof of their den collapsed and got them. But just before, they had been fed the meat of a woolly rhinoceros by their mother, that preserved well enough in their stomachs to get a DNA sample from. This allowed researchers to reconstruct the woolly rhino's genome from a time when it was about to go extinct. It was found that the rhinos were genetically healthy. They had no signs of inbreeding, suggesting a healthy population only a few centuries before the species completely vanished from the earth. The extinction of the woolly rhino was thought to have been due to one of 3 things. One is that they became too inbred and lost viability. The second, that humans overhunted them, and the third was a disfavorable change in climate. Now there is evidence that it wasn't inbreeding, but it also doesn't appear to have been humans either, because that would have shrunk the gene pool as well. That leaves a rapid period of climactic warming. In short, it got too hot for them and changed their habitat disfavorably. That lines up with a period known as the Bowling-Allarod interstadial warming period. Number 1. And then there's a new problem with the standard model. Just when you think the standard model is safe with another proof, out comes a completely different finding that calls it into question again. So the standard model of particle physics, as mentioned in another entry on this list, is highly successful, and it catalogs all particles and forces we know exist in nature, and scientists have been trying to break it for decades to no avail, but maybe now there is a true crack in it. It comes from neutrino research, which are ghostly particles that rarely interact with anything, but have been detected and do exist. They also hint at a particle nature for dark matter. It could be another weakly interacting particle like the neutrino that our detectors are simply not calibrated to detect. But the reason scientists were trying to break the standard model was because it doesn't seem to connect gravity to the other fundamental forces of nature. Break it, and it gives you the starting point for a new, better standard model. The researchers were looking at 2 aspects of what interactions neutrinos do rarely experience, and a discrepancy came up in one of them that did so in such a way that some of the alternatives to the standard model actually explain better. While this doesn't disprove the standard model, it does provide a roadmap for researchers to further study neutrinos and probe this apparent crack in the standard model. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently noting that I passed my 10-year anniversary of this channel last month. Doesn't feel that long. Time flies when you're having fun, but yes, it's been 10 years since I made that fateful video on Tabby Star, not knowing what this channel would turn into. Thanks everybody for sticking around with me, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.